Hello, everyone. So I am finally back from Defcon after 4+ days in Las Vegas, and think I'm mostly set up here right now. I did figure out there was a resolution problem, so that's been changed. Hopefully, this looks a little bit crisper. We'll see. This computer is already dying right now. So if anything happens to the stream, I'm sorry. It's all in the name of high resolution. Hey, Bay. Good morning. It's early for you out there, isn't it? Oh, wait, no. It's 2 p.m. here, 11 p.m. or 11 a.m. there. My time zone has not updated over here, and I'm confused, apparently. So yeah, DEF CON was awesome. I got my Wi-Fi Pineapple, which is essentially kind of like a man-in-the-middle device for wireless networks. When your computer is looking for its saved wireless networks, it'll say, "Hey, are you this network?" to other networks, and this device says, "Yes, I am the network you're looking for," allows you to connect to it, and then essentially man-in-the-middle's your traffic, and it can look for all sorts of fancy things. It is a device I've been looking to get for a while, but because I was in Vegas and at DEF CON, it seemed like a good time to get it. I also got implanted with an NFC chip, which my wife was less than thrilled with, but it does allow me to read my body with NFC readers, which I will hopefully demonstrate here. The process was as painful as you'd probably expect, being injected with a chip at a conference. It is not something I would recommend for the squeamish. I did not actually show you what happened there, but I used my NFC reader to read my NFC tag, and right now all I have is my virtual business card stored on it. I'm looking for ideas on fun things to do. We'll figure that out some other time. And finally, I got my training lockpick set, mostly for my kids because I think lockpicking is cool. And getting them familiar with how insecure daily life actually is a good way to grow up fast. All right, so de-obfuscation. I've been busy on that front. Relatively. Got the Shift Refactor package published. It's in the chat, so if you wanted to follow along, you can download that. There's also the current state of code that we've been working on in the chat as well. So if you're looking to follow along as opposed to just view me here, you can clone the second repository, do an npm install, and you will get to this state right here. You'll have stage 1, which is the first obfuscation stream. Stage 2, which we went over last week. Stage 3, we'll copy and then I'll upload that. And you can see where we are. I also, let's see. So Shift Refactor, actually, let's go over that a little bit now that it is properly published. This is a preview right now, mostly to tell you or let you know that this could change, especially as we go over things in these live streams. A lot of the methods and functionality in here are things that I've been using for a long time, but Shift Refactor is it all packaged up into an API. So making sure that API is rock solid, is easy to use, doesn't have weird bugs. That'll be what we're going through during these live streams. So the API may change, but I mean, half or probably even more than 90% of what exists in NPM is stuff that is called unstable or preview, but then never gets updated and is what it is for 4 or 5 years. So that could very well be what we're dealing with here. So by that, I mean to say that it is probably relatively stable. We've gone over the usage so far, but some of the methods that you might not have seen yet. So let's see, query from we used a little bit, print we use every time. Rename we used a little bit, just basic identifier renaming. Deletion of nodes we dealt with. Replace, I'm not sure we've actually replaced anything yet, but this allows you to submit a query or individual nodes to replace, and then replace them with either shift nodes or JavaScript source. Replace recursive takes in only queries, so not actual nodes, and then something to replace those nodes with, and it will continue calling that, it'll continue running that query after every replacement until that query returns nothing. So if you're doing something, so it's changing parts of a subtree that may itself need to be changed when it's part of a larger tree, that is the type of method that you'll use. You'll just basically continue doing something over and over again until no more replacements need to happen. Insert before, insert after, relatively straightforward. You can insert statements before other statements or after. Utility methods. So these are methods that I found myself using a lot in my code. So this is basically just using shift refactor methods, but wrapped up into a utility part of the library because they're so commonly used. This is one of those things that actually that I'm not thrilled with. It would actually be nicer to have these in a util library. But for now, while I'm discovering what these utility methods are, there's going to be bucketed in one place, and we'll deal with that as we deal with it. But convert computed to static, we dealt with that before. It converts anything where there's a computed property or computed member and translates it into a static version of itself, where it's still valid. This is very commonly done right before the end of a refactor or deobfuscation, because a lot of the obfuscation involves munging up a lot of those properties. So this is just something that once you're done deobfuscating all those strings, you then just convert them to static, so you have less things to deal with. Expand Boolean. This is a common method for minifications to squash down literal Boolean expressions. So you get true being not 0, false being not 1. This just translates those back. Normalized identifiers we went through last time, I think. Basically makes it so that there is each identifier is unique in the entire program, which makes it easier to query. We did come across a bug last time, which I do need to file on this repository. So it's not exactly bulletproof to use yet, but the concepts, you could easily, if you wanted to fix that right now, you could take the implementation and just fix it yourself. You just have to make sure that you're not renaming any identifiers where they might be used outside of your scope. And that's it. So also, due to my brain farts with Shift Query last time, I made an interactive demo website for Shift Query, which you can get to at jsoverson.github.io, shift-query-demo, which allows you to visualize the output or the results of a query when using Shift Query. This will probably grow. I want to have a sidebar of the actual nodes so that I can understand more of what makes up their AST nodes. But right now it's just a quick visualization. So if we want to look for binding identifiers, we can do that. And you get these things. Would like to have this autocomplete too. So if anyone else is looking to contribute, you are more than welcome. Let's see. What else we do? Oh, we don't have any computed member expressions here. Static member expressions. And we can see all the accesses there. Call expressions. Well, yeah, there are some things that are overlapping. I try to make them different colors to make that a little bit more clear. It's not awful, but those colors are hard-coded. So once you get to about 15 or something results, then it becomes a little bit hard to read. Yeah, one thing that was killing me last time was that the concept of the translation of the CSS selectors to an AST selectors with Shift Query was confusing me because of the way CSS selects descendants, and I was trying to select individual nodes, and that is something that I need to get better at. All right, on to obfuscation. So what I was planning on doing with obfuscation this time was to start diving into some of the more advanced features of JavaScript-obfuscator. And the first one that I wanted to play with was the self-defending option. So we have this here. And I keep on showing you this by default as if like you're gonna see it and be like, yeah, I know exactly what that's doing. Clearly, you're not supposed to, because this is supposed to be obfuscating and altering or inhibiting your ability to immediately understand what's going on. But the gist behind self-defending code is that something something about the code's behavior should change in a negative way if the integrity of the entire package or bundle has been compromised. So that's the general gist of self-defending code, or the way that I at least use that term. I have not actually played with this feature yet, so we're going to explore what this actually does. All right, so if you are following along, we're just going to do a straight copy of stage 2, rename that stage 3, and we are going to, let's see, we're going to change the obfuscation here. Let's, for now, get rid of some of these so that we can reduce the amount of obfuscation that is going on. And then let's check out self-defending and see what this actually does. Self-defending, true. All right, so we are in stage 3. And we want to node obfuscate.js. So now we have original obfuscated. So let's format it. So we get our code down here. You'll see that's still doing the array, the string extraction to an array. Let's see if we can get rid of that. String array, cool. String array, false. Just to clean up the code more so that we can see what that self-defending code is doing. Okay, so we have our class down here, which is completely unchanged. And aside from these computed member expressions and some renaming and this escape sequence, it looks as though it is completely unchanged. So that would mean that all of this code up here is new. And we need to figure out what this is doing. So let's run our code to see what it looks like. Ah, hold on. So well, hold on. Let's so either there's a problem in the obfuscator, or I've already compromised the integrity of this bundle enough where it is breaking itself. So let's do node. Well, first let's run our original. So this is what we get: hello world, hello reader. Just a very, very basic class that prints to the console. So now it's node obfuscate.js, node original obfuscated.js. That prints what we're looking for. Now let's see what happens when we format it. And now it breaks. All right, that's kind of cool. So just the act of formatting this code has now caused it to break. Let's undo that, try it again, and now it works. All right, that's cool. That's cool. I like that. So in a browser, actually, let's see what this looks like in a browser. All right, stage 3, index.html, HTML, body, script, source equals original obfuscated script. Okay. If you have not ever used HTTP server, it's actually pretty useful. Actually, you know what? Screw that. If you haven't used NPX yet, that is something that I highly recommend you have installed globally, because that would allow me to do something like what I will just show you without installing HTTP server globally. So NPX, so now I want to run HTTP server, and I'm using NPX now. NPX is going to find the most appropriate HTTP server installation. Use that. If it can't find it, then it will download it from npm, cache it locally, and then run it itself. So if I had HTTP server installed within this project, then npx would use that. If I didn't and I had it installed globally, npx would have used the global one. If I didn't have it anywhere, npx would have taken the chore of installing it and then running it without actually ever contaminating the global or local projects or environments. So now we can do npx HTTP server, set that up locally, and now we have our index.html. Let's go over to the console using Safari. What the? I guess Safari's default here. Too much recursion. All right, so we break in the browser too. Let's go back to this, and we get hello world, hello reader. All right, cool. So that is consistent. The error is consistent, so that is very likely the expected outcome. So we have some code that we need to figure out. What seems strange, though, is that it looks as though our class is, or our class and code is entirely replicated down here. And if that's the case, I'm wondering what this code is doing, or if it is just completely separate from my class. It's not intertwined, and it's not, it doesn't seem dependent on each other. So if I just delete this, then it works. Yeah. So getting around this particular defense or obfuscation might actually be a lot easier than I was expecting, because it seems as though if I just strip out all the self-defending code, it's going to work perfectly fine. Well, let's do that. All right, so we have deobfuscate right here. This is what we were doing before. Let's we could keep on building this deobfuscation on top of other obfuscations, which would be valuable and would end up with a very, very comprehensive deobfuscation script, but would also make each individual deobfuscation slightly more complicated because I'd have to make each more resilient. And I'm not sure that that is going to be worth it in a live stream setting, because if you've been here before, then you already see how stumped I can get with very, very simple things, because just talking out loud during this really does alter the way my problem-solving part of the brain works. So I think we're going to keep it simple with the end goal of taking each of these individual concepts and then picking and choosing what is relevant for a particular obfuscation, and then just tying them together there, instead of having one giant deobfuscation script specifically tailored to deobfuscating JavaScript -obfuscator type obfuscations. Wow, that is a lot of the word obfuscation coming out in a very, very short period of time. All right, so we have our basic self-defending here. We don't need our index.html anymore because it's not doing much. Let's see. So let's get rid of all the other stuff now. So refactor session, we need that. And we need the print and the convert computed to static at the bottom. So now what we're looking to do is just get rid of this. We're trying to, actually, you know what? So this is in an immediately invoked function expression, and our code is completely self-contained at the bottom. So what we could do is just slice out the statements here and then replace the entire script with those statements, and that'll work perfectly fine. So let's see here. Let's get this into ASD Explorer. So we have one expression statement, we have a call expression, we have a callee, we have a body, and these statements are what we want it to be at the top level. Because if I remember correctly, our original is in an immediately invoked function expression. Okay, so we should keep that because altering that would alter, well, we could potentially alter the behavior of our script. Okay, so we want to so we have a class declaration. So our code starts at the class declaration. So we just need to get rid of these first 3 statements, and that would be it. And that would be completely taking care of this obfuscation. I'm very, very curious to see if this actually works as seamlessly as I am expecting. It worked when I did it manually, and it should work just as easily, but it just seems surprising that this self-defense mechanism is so trivially bypassed. All right, so refactor dot delete. We want to delete. Can I actually query statements? Yeah, cool. All right. So what I want to do, let's see. So node shift query original obfuscated. So script. Can I do immediate descendant statement? Oh yeah, that's obvious because that is this this expression. So I did get what I wanted. So script, the first statement was a expression statement with a call expression, so it was getting this. What we want to do is get. Actually, we could. Let's see. So statement. We want to get all the substatements of that expression statement. Will this work? No, that's not going to work. All right. So this is going to be a JavaScript de-obfuscation stream, and also how the heck to use query statements on an AST stream. All right. So we have the first statement there. We want the let's see. Can I query? You know what? This is unnecessary. I did so much trying to get everything consolidated into one query last time. Really, all I need to do is actually just poke the AST itself. All right, so we have the tree, statements. First statement is a call expression. Callee. What is after that? So callee body. So body is the statements here that we need to remove the first 3 statements from. All right, so const internal statements equals tree statement 0 callee body. Let's make sure that actually works properly. Node de-obfuscate cannot read body of undefined. So we have an expression. So I did not go deep enough. So I got a comment last time that I bounce around screens too much and are too quickly. So I apologize for that. If you ever want me to slow down, please ask questions. I have this fancy monitor here. I've got questions or comments that I can see. And I will do my best to stop and explain things as appropriate. All right, so the reason why that was an error was because I got the first statement in this statements list, and I was accessing callee right here without diving into the expression here. So that is something that if you are digging through ASTs will probably not be too uncommon for you, just because I for one, and I would guess probably most people, don't have every possible AST data structure stuck in my head. All right, so node de-obfuscate. We get all the, so this is the function body, and we get all the statements that we're looking for right here. So let's get these statements. And now we have the statements. So really, this should be as easy as just deleting. So we want to delete the first 3. And I could just do it like this, because it'll just, it'll shift everything up 1. Let's see if this actually works. No, deobfuscate. Input char code at is not a function. So this, so this is an error out of shift query, which to me indicates that I have not made delete take nodes, and I only have it taking queries, which is not cool. We're going to open up an issue real quick because I think I've dealt, and I do not have my GitHub account set up on this computer. I need to make an issue. Anyone else want to make an issue? No? It would be helpful. Otherwise, I'm going to have to jump over this computer over here. Because I think I dealt with this last time or even the time before. And that is turning into a problem just for things like this. I want shift refactor to work not strictly on queries. So I'm going to quickly make an issue. Delete does not appear to take in nodes. Bug from stream. All right, so I will fix that. I could dive into the API or the internal code of shift refactor. For the sake of this stream, I do not recommend this because these are methods that are not intended to be public. So this is a queue deletion method, which we are going to do here. Oh, actually, so delete. This is actually bringing up something that if you are doing extensive deobfuscation on big trees, you're going to run into some performance problems because a lot of these methods are set to auto cleanup by default. So let's see, let's go back over here. Preview release. So there's a option you can pass to refactor session, auto cleanup : false in an object, which will not auto cleanup after itself. So when you delete nodes, those nodes do not get deleted immediately. They get queued for deletion so that you can operate on a bunch of things in the tree and then clean everything up all at once. That gets to be a little bit complicated because then you have to make more effort to, you need to expend more effort to understand the state of the tree at any particular time. So it's not recommended unless you're going through a lot of refactors. But what it means here is that if we are going to do this, we can't just queue deletion 0, 0, 0. We need to queue deletion 0, 1, 2 because those nodes have not actually been deleted. And now we need to refactor cleanup. Hopefully this works. No deobfuscate. Yes! Oh, I just get so happy sometimes when code works right away. Especially when I'm talking out loud because we've already seen what happens there. All right, so this is our code, and this looks like exactly what we started with, minus the names, and now we can run it, and it does exactly what we want. So this self-defending code is basically just a wrapper for other code that sabotages the bundle if it's tampered with in any way. This is clearly ineffective for somebody who's genuinely determined. I get additional benefit. I have guilty knowledge because I know the obfuscator I'm using, and I was able to see that code was added. So I was able to easily separate the code I was looking to extract, and the code that was additional and on top of that code. It made it easier for me to understand that. But this kind of highlights one of the problems with obfuscators and automatic obfuscation with JavaScript, because they have to do things in as safe a way as possible to account for as much random JavaScript that could be taken as input, which means that they just kind of have to wrap things around it, or do the identifier shuffling and stuff like that, things that are safe to do intertwined, but self-defending code, to be effective, needs to be intertwined because I shouldn't be able to extract it so easily. So that completely obviates or completely removes the self-defending hurdle from the code. So let's move on to something else. JavaScript obfuscator. So let's see. Control flow flattening. That sounds like it's going to be useful. I'm not going to do that right now because I want to test that myself in order to make sure that I have a representative sample of code so it'll do what it needs to do more effectively. The stuff here is not super exciting. Let's go back to the options here and see if we can find something that we want to play with. All right, string array, we've already dealt with that. That is unexciting. Transform object keys. Target browser, I don't think we need to worry about because I think that's just a compilation nuance. Source maps, we don't need to deal with. That is for debugging purposes, presumably. Self-defending, we just bypassed. Seed, we don't need to worry about. Rotate string array, we dealt with last stream. Reverse strings, these are, again, compilation details. Rename globals, that'll be... I'll want to tackle that, but I'm not going to do that now. Identifier names generator, we've already dealt with. Ooh, debug protection. This one sounds like a good one. Let's do that. Oh no, these are defaults. All right, so now, so we have self-defending. We'll keep that on for now. What was it, debug protection? True. And let's see, well, let's turn this off. I will commit this with true so that our script, oh no, I have the default. I've got the removal of those nodes there, so we'll just deal with this. No, I will remove this for now, figure out what debug protection is doing, and then deal with that afterward. All right, so node obfuscate.js. Let's check out our obfuscation. All right, so this is definitely new. There's new stuff at the bottom. Our code is, again, completely self-contained right here. And we have code at the top. So it looks like it's another wrapping scenario. So var e equals this function. This function is immediately executed. F is not empty array. Is an empty array false? So an empty array is true. So not empty array is true. Okay, so F is true. These are one of those magic variable type things that confuse me. Oh, so then it gets set to false down here. So var I equals F. So there's some magic happening here. I'm not going to worry about figuring out exactly what this is doing yet because I want to see its behavior first. You got an immediately invoked function over here doing something, looking for functions here and other stuff here. And the code at the bottom. So it looks like it is creating a new function that has an infinite loop in there or something like that. Let's get our convert computed to static to make this easier for us to look at. All right, so creating just an arbitrary function. What happens if you, so you pass a string to the constructor method? What does that do? What is, oh, wait. No. There's a construct. I don't know what this is doing. Let's see what it actually looks like. All right, so we have our original obfuscated. So node original obfuscated gets exactly what you would expect it to get. Let's check out what's going on. Let's see. So let's see what's going on. Let's see what t is. Console.log t. Okay, so we are, let's get our index.html back, which I should not have deleted, because that'll make it easier for us to see its effect on having the DevTools open. My guess is it occupies a lot of time going through and essentially just creating anonymous functions with debugger statements in them, so that if you have the DevTools open or if you're trying to debug, you keep on being redirected to, you keep on getting your developer session hijacked. That is what I would imagine debug protection, a feature like that, to do. That is what the code looks like it is doing. And since it is just wrapping our source like last time, it doesn't seem to be intertwined, we can probably just deal with it the exact same way. Let's see, original obfuscated script. So npx HTTP server. Go back to here. Yeah, so here we go. So we got debugger. Just as soon as I load the page, we have debugger in what is an anonymous function that is called here. So we do get the stack. We can see that we are in a very weird part of the program. Let's see what this looks like. Well, first off, step over, deactivate breakpoints. Okay, so deactivating breakpoints. Wow. All right, so this debug protection, well, I'm console logging. Let's see what happens if I get rid of that console log. Oh, this is hurting Firefox. Well, that is effective debug protection. Although, I wonder if that's, no, that wouldn't be an infinite loop, because then I wouldn't be console logging anything. All right, so we are back. Let's get out of this. All right. So I wonder if this choke on Firefox's part is due to the console log or is due to the debug protection. Let's open up Chrome and see what we get there. What is that? 8080. All right, so we are opening. We get this. Let's turn off breakpoints. Go to our console. Okay. So I'm going to guess that it was the console logs that were choking up Firefox. Because removing that, I'm not getting into any sort of destroyed session over here. It is definitely taking its sweet time to run this. So let's check out some performance before we dive into the defeating of this. So this takes up 100 milliseconds. So that is, it felt like longer, but that is just pure JavaScript execution. So our original script is very, very simple. Let's see actually how quickly that runs. Original.js. Let's check our profiling here. So yeah, our original JavaScript takes 1 millisecond, or that is how much or how low we can get at the performance auditing level. So this debug protection adds a good 100 milliseconds on top of that, which is a 100x increase for this simple script. It's probably much lower when you consider large scripts that you want to protect, but even still, that is not a trivial amount of protection. I mean, that is not a trivial amount of execution to add on top of anything, especially if you were in a hot path. All right, so in Chrome, we probably still break. Okay. Yeah, we still have our same problem here. We keep on diving into deeper in the stack, and will eventually probably choke out. All right, so this seems as though it is just as easy to bypass as the other one by just cutting out our code. So we have this function at the root level, which is surprising because any sort of modification to a JavaScript source, if you're modifying anything in the global space, you are running a fairly big risk of colliding against something else. But makes it easy for us to cut this out. So we actually can, well, let's put this into our ASD Explorer. So we have two statements here. All we need to do is get rid of the second one because that is the global function I was just talking about. And for our call expression, we need to just get rid of the first two. Let's see if that works. All right, so we have our deobfuscate here. We can deal with this. So we want to delete, so refactor dot q deletion tree dot statements 1. So that is the second statement at the root level, the function declaration, which we just want to get rid of. And internal statements, we can reuse this right here because it's doing the same wrapping of the IFI. And I think we just need to get rid of what, 2? So statements, we have try catch. Oh, this one down here. All right, so we have callee, body, statements. We start the class. So yeah, we're just gonna get rid of the first 2. Clean up, convert it, computed to static. Let's go to our node deobfuscate.js, and we get exactly what we're looking for back. So output.js, node output.js. And we have now gotten rid of the debug protection. So this is, some of the people who are watching me do things like this, they might think of like, well, in a browser setting, you've got these resources being sent to you. You don't have the ability to manipulate them like this, so that you're just stuck with whatever's being sent to you. And some sites are highly dynamic and highly dependent on being served from a web server, that you can't just necessarily just download everything locally and modify everything yourself and do these deobfuscations. And that is kind of true for most environments, but you can easily set up a proxy that can modify content as it streams through, so that once it gets to your browser, it's already deobfuscated. And that gives you the ability of manipulating a web application with a much greater degree of control than just dealing with what they serve to you by default. And actually, I've also, let's see, YouTube, Jared Overson, my name, intercept, I think. So intercept requests and responses with Chrome DevTools protocol. I will spare you the actual playing of that on this stream. But I go through this on Medium and on YouTube about how you can use the Chrome DevTools protocol, which is a JSON protocol to Chrome, the browser. It allows you to interact with the DevTools protocol. One of the things that you can do with the DevTools protocol is intercept requests. Intercept. Let's see. Set request interception. So this allows you to set patterns for requests that you want to intercept. And then once you've intercepted them, you can then grab the bodies, and then you can do whatever you want with the bodies, and then serve the modified body up to the browser, so that when you are dealing with the JavaScript in the page, you get it modified the way that you want it to be modified. And this alleviates dealing with SSL certs or all the normal man-in-the-middle problems that come around from using a proxy, so that you can actually just do this all with Node, with Puppeteer and Chrome and all the tools I'm talking about in your own environment, so that you can just distribute that as a package, and then people can use that in order to just pop up a Chrome browser that intercepts what you need to intercept and deobfuscates and massages JavaScript however you want. And that's actually a really super powerful way of dealing with JavaScript on the web, because you get all the power of Chrome, all the power of DevTools, and all the power of man in the middling the application, all in your common node environment. So this is definitely practical application stuff. And you can use this for also like kind of hypercharging your troubleshooting and debugging. Especially if you're dealing with things in production, you might not exactly have all the tools necessary, source maps, whatever else. So by just taking control of the JavaScript yourself and doing what you need to do with it, you can troubleshoot things a lot more effectively. So I think that is probably all we really have time to do this stream. I guess I'll finish out the stream and then combine these two together in order to deobfuscate them in one fell swoop. So let's see, node obfuscate.js. Let's go here, original obfuscated. Let's check out the nodes that we need to get rid of. Well, let's fancy that up a little bit. Let's get rid of Chrome. We don't need you anymore. All right, so we have at the root level still that same function we need to get rid of. Up here, let's take a look for our class, and it's still just all at the bottom. So actually, we could just delete everything except the bottom ones here. This is what I was talking about making the scripts more resilient. I'm just going to delete the hard-coded indexes up top. So deobfuscate.js. So we want to delete that, and then delete 0, 1, 2, 3, 4. And clean up node deobfuscate.js, and we get exactly what we want back. Cool, and this is our original script. So you can easily, well, you can combine the methods we're talking about with the other stages in order to deobfuscate even more crazily malformed JavaScript. Well, you know what? Let's do it. Let's see how crazy that actually is going to be. So Unicode escape sequences, to do that, rotate string array. Ooh, this might get hairy. I'm not sure I'm going to be able to do this in 13 minutes. String array 2, true. It's so hard to talk while coding for this long. Yeah. I'm learning a lot about myself and how to talk while coding, so it is valuable, but holy smokes. All right, node obfuscate.js. Let's take a look at this monster now. Yeah, I mean, this looks terrifying. Like if you know that you or if you don't know what you're looking for, and you start off with this, like, look, our strings array is growing with all the other crazy code that we're adding, or that is getting added automatically. You got this things, you got stuff looking for cookies and timeouts. Wait, cookies and remove cookie and get cookie. Where did this come from? Decode URI component. This is new. All right, so we have some relationships here with these with this code, with these protections. That's interesting. So let's find out where our class is first. So our class is still, so even with those protections changing, our code is still completely self-contained right here. So that we can still extract it. So we can do the other obfuscations and then extract our code and still be good to go. But that is interesting. Definitely want to take a look at this at some later time to figure out what's going on right here. Because that is a feature I did not know existed. I mean, even still though, I trust that you have followed along enough so that you understand exactly how we've been doing what we've been doing, and we can get around this. So even with rotating defenses and rotating the self-defending code and rotating debugger protection, because this is not actually intertwining with the original code, it can still just be stripped out. And that is just such a hard problem in protecting JavaScript. And some obfuscation techniques and obfuscators do this, but every time you do it, it gets more dangerous. The code is more likely to break in strange ways. It slows down performance. You saw that the debugging code itself already added 100 milliseconds to the execution in Chrome on a relatively recent Mac. So on a mobile device, that would just be foul. But it's a very, very hard problem. And because so much JavaScript is sent down on very, very well, I mean, so much JavaScript is sent down on every site basically that exists, and it needs to be as fast as possible. You'll see people like Adi Asmani, Paul Irish, Paul Kinlan, a bunch of other googly people talking about web performance, which leaves so little room for defense of code. So you have to send down just the most streamlined code possible. And when you do that, you are streamlining the delivery of the intent behind your code. So to protect your code, you need to do a lot of destructive transformations. You need to intertwine code with other code, so it's harder to extract. And it's a very, very, very hard problem, which is also one of the reasons why I do this, in order to show just how silly most trivial obfuscations actually are. All right, so let's pick out some of our stuff from stage 1 and 2. All right, I'm just gonna copy and paste a bunch of this and see what happens. Not even gonna look at it. Just gonna put this right here and see if this works for the stuff that we've turned on. All right, so now we need to obfuscate. We need to de-obfuscate. Oh no, something horrible has happened. What is going on? Destringify offset. So what is going on? That was taking far longer than I expected, so I killed it. I wonder what's going on here. So it wasn't that. Destringify offset, shouldn't be that. So refactor.replace was taking a very long time. Whoops. Why is that? Huh. So this is very likely a refactor bug that I need to fix. Maybe it's cleaning up after every replacement, which would definitely kill performance. Let's see here. All right. Well, it doesn't look like we're gonna get through the full deobfuscation here right now, but all right, so let's see. All right, so replace. So no, it's only replacing at the end. All right, well, I'll need to figure that out. That'll be a good test case, and I will improve the performance there. I wonder if it's actually the query. Nope, it's not the query. So this is, all right, well, I'll troubleshoot this at another time. This is a good enough place to stop. I will get rid of this stuff in stage 3, and I will commit and push the work that we did during the stream, and I'll try to clean up the entire deobfuscation thing and try to troubleshoot this performance issue and put that together as well. But for right now, this should be enough. So no deobfuscate, no obfuscate, no deobfuscate. All right, cool, that works. Git status, git commit. I actually need to. All right, I'll deal with this off the stream. Thank you very much. I really appreciate you stopping by. This is fun. I'm learning a lot about obfuscation techniques with JavaScript-obfuscator. That is cool for me. If you have any other obfuscation topics or questions, or how to use ASTs, how to use shift refactor, how to use the shift suite in general, feel free to comment on YouTube stuff or reach out to me at Twitter at JSOverson, and I will get back to you. Cool. Thank you very much. I will see you next time. Later all.